Hello, this is a video over 310 notes, and this is derivatives of inverse functions. And we're going to talk about regular inverse functions, and then we're going to talk about trigonometric inverse functions. So what I want to do first is just quickly talk about what an inverse function is. And an inverse function is something where you switch the x and y values, okay, and solve for y. Okay, the notation that we have, no, that's not right. Okay, the notation is we use like y to the -1, or we use f to the -1 of x to denote that this is an inverse function, okay? And so that's that. I do want to talk about that inverse functions are reflected over the line y equals x, okay? And then I do want to draw a quick little picture over here if we're talking about the derivatives of inverse functions, okay? So the best way to explain this is by using a picture. And the two equations that I'm going to talk about that are inverses of each other are, I'm going to use, we're going to use the equations f of x is equal to e to the x. Okay, and the inverse of that function is the natural log, okay? Natural log function, ln of x, okay? And so what I want to do is draw a quick little picture of what we're doing here. And I'm going to do this right here. I'm going to draw an x-axis, or y-axis, and an x-axis. So here's my x, and here's my y-axis. And if I'm drawing an inverse function, a function that's inverse, I'm going to draw the line y equals x, okay? And the reason why I'm drawing that is because inverse functions are reflected over the line y equals x, okay? So I'm going to call this y equals x. Okay, and then I'm going to draw the function e to the x, okay, like this. And then I'm going to draw its inverse function, the natural log function, like this, okay. And I like to use these examples because it's kind of the easiest way to explain this. And so one of the things that I want to talk about here is that on the function f of x, okay, we have the point a, b. Okay, that's just a point on the function f of x. Now the function, the inverse function, okay, f inverse of x, has that similar point, but it's just the point b comma a. Okay, and so what we've been doing in calculus is we've been finding the slope of the tangent line. So the way I want to write this is I'm going to draw a tangent line right here, okay, and I'm going to draw a triangle here because when we measure slope of this tangent line, we take the change in x and we take the change in y, okay, take the change in y, and if we wanted to denote the slope of this line, okay, then we're simply going to take f prime of a, the derivative at a, and that's equal to the change in y divided by the change in x, okay? So what I want to do now is talk about what would happen at the slope of this line, the corresponding point on inverse graph, okay? And if I'm gonna say, and here's how I want to say this, the slope is equal to f, let me erase that, it's going to be f inverse prime of b, okay? That means the slope of this line, okay, of the slope on your inverse function. So now, what I want to look at is this distance here and this distance here are very similar to this distance here and this distance here, okay? So this is really my change in x, okay? And this is my change in y, okay, if you look at those triangles. So if I were to find the slope at that point, at point B, then that's going to be the change in x divided by the change in y. Okay, and these two things are reciprocals of each other. Okay, and reciprocals. And what I'm going to do, guys, is I'm going to use this picture here, all right? I'm going to use this picture to kind of explain the remaining problems on how to calculate the derivatives of inverse functions. Okay, but the main thing I want to talk about and reiterate is that, first of all, they're reflected over this line y equals x, okay, and that is a slope of 1, y-intercept of 0. Okay, the x and y values on my function are switched on my derivative, okay? And if I found the slope of this tangent line at this x value a, I get the change in y over the change in x. Okay, if I find the slope of my inverse function at b, now b is the x value here, that was the y value here, all right? And then that is the reciprocal of this derivative, or this slope. It's the change in x over the change in y. We just switched my numerator and denominator. Okay, so I hope that this is helpful for you. I'm going to use this picture to do the next couple videos. So I hope you enjoyed this, and we'll see you in the next video.